Here is how this measurement method works. Pitot tubes have a rod-shaped measuring element that is inserted into the pipeline perpendicular to the flow direction. On the front and rear of this probe are several holes. Two separate tubes connect these holes to a differential pressure sensor. With its two pressure chambers, separated by a diaphragm, the tiniest pressure differences in the flowing fluid can be precisely measured. The individual pressure taps are distributed along the entire pipe cross-section to ensure a representative measurement. If there is strong interference in the flow profiles, it's advisable to fit a second Pitot tube, rotated by 90 degrees. If the fluid is not flowing, the pressure before and after the probe is essentially the same. As soon as the fluid starts to flow, an additional impact pressure against the front of the probe is generated, also known as the dynamic pressure. On the rear of the probe, in contrast, only the static pressure, which is not related to the flow, is still measured. As a result, different values are detected in the pressure chambers of the sensor. Higher pressure against the flow and constant pressure on the rear of the Pitot tube. This pressure difference is a direct measure for the flow velocity and thus the mass and volume flow in the pipe. The higher the flow velocity and therefore the dynamic pressure, the greater the differential pressure measured.